As we continue the screencast on Lecture 7, Middle and Late Childhood Development, we turn our attention to cognitive development. An important feature of elementary school years is a marked growth in children's cognitive sophistication. Piaget refers to it as the period of concrete operations from 7 to 11 years. And what Piaget hypothesized is that children enter a new stage of thought, concrete operations, between 6 or 8 years. That's when it starts. And children can perform concrete operations and reason logically. They are able to classify things into different sets. He defined the operations as a basic cognitive structure that is used to transform information or operate on it. So in looking at Piaget's concrete operational stage, one achievement that is characteristic of this stage is the ability to engage in mental operations that have reversibility. For instance, children understand that subtracting a few pennies from a jar can be reversed by adding the same number of pennies to that jar. Second, concrete operational thinkers are actually capable of the concept, what he calls the principle of decentration. That is, they can focus their attention on several attributes of an object or event simultaneously and understand the relationship among dimensions or attributes. They understand that objects have more than one dimension, for example, weight and size, and these dimensions are inseparable. A pebble is both small and light, a bowling ball is both small and heavy, and a balloon may be large and light, a car is both large and heavy. So thirdly, children shift from relying on perceptual information to using logical principles. One important logical principle is the identity principle, which states that basic attributes of an object do not change. For instance, if a bale contains 32 pieces of lumber, a house built using all this lumber will contain 32 pieces. The equivalent principle is closely related to the identity principle. It states that if A is equal to B in some attribute like length and B is equal to C, then A is equal to C. For instance, if Mary wears the same shoes as Denise and Denise wears the same shoe as Valerie, then Mary can wear Valerie's shoes. Therefore, the operational thinking enables the child to say Mary can wear Valerie's shoes. So as we continue with Piaget's concrete operational stage, we all know that Piaget's famous conservation experiments demonstrate all three features of concrete operational thinking: reversibility of mental processes, decentration, and a change from perceptual to logical judgments. So if one type of experiment, as in conservation of liquid, the child is shown two identical glasses, both of which contain the same quantity of colored liquid. Remember that experiment with pre-operational children where they had failed the conservation test. After the child agrees, and in looking at children in the concrete operational, after the child agrees that both glasses contain the same amount of water, the interviewer pours the liquid from one of the glasses into a taller glass that is thinner and asks, does the taller glass have the same amount of liquid, more or less liquid? Pre-operational children, if you can recall, often say that the taller glass contains more, but the concrete operational children say that the quantity does not change despite its appearance. So Piaget is assuming that the child understands the concept of same, more or less. And a critical part of the experiment is questioning the child why the amount is the same or different. And that really tests the child's cognitive abilities. A child in a concrete operational stage would say if you poured it back into the previous glass, it will look the same, as in understanding the concept of reversibility, and can also say the glass is taller and thinner. Decentration is acquired there. And then you didn't take away anything, applying logical thinking. So the pre-operational child, even if he gives the same answer as a concrete operational thinker, that child would be in the pre-operational stage, they would be unable to explain why that answer was correct and might be easily persuaded to change his or her mind. So the experiments with liquid mass actually demonstrate conservation of substance, mass, substance, that is, understanding the amount of substance does not change because its shape and configuration changes. So the conservation of numbers, understanding that the number of objects present does not change when the objects are rearranged. So once a child can understand that certain changes, yes, have been made in terms of configuration changes, but the substance, as in a substance, does not change, then they have acquired that concept. Likewise, in terms of numbers. So in a typical number experiment, the child is shown two identical rows of buttons. After the child agrees that the number of buttons in the two rows is the same, the buttons in one row are spread out. Concrete operational children can therefore reverse the operation, and they can decenter and consider both length and density, and of course can use identity principle to conclude that the rearrangement does not change the number of buttons in a row. So this is something I want you to pay attention to in terms of the different types of conservation tasks or experiments that Piaget did, and to demonstrate the features of concrete operational thinking in concrete operational children. So an important hallmark of concrete operational thinking is a better understanding of quantitative relations and what we call relational logic. Can you recall an occasion when your PE or PT teacher said line up by height from tallest to shortest, or maybe from shortest to tallest? Carrying out such an order is really quite easy for concrete operators, who now are capable of what Piaget referred to as mental seriation. And let's look at what this means. So mental seriation, the ability to order stimuli along a quantitative dimension such as height or weight. By contrast, pre-operational children perform poorly on many seriation tasks and would struggle to comply with the PE teacher's requests. So concrete operational thinkers have also mastered the related concept of transitivity, and this is the ability to logically combine relations to understand certain conclusions. If, for instance, John is taller than Mark and Mark is taller than Sam, who is taller? Let's repeat. John is taller than Mark and Mark is taller than Sam. Who is taller, John or Sam? So it follows logically that John must be taller than Sam, and that the concrete operational thinker grasps the concepts of transitivity of size relationships. Lacking the concept of transitivity, a pre-operational child, when given the task, might insist that Sam and John stand next to each other to determine who is taller. Another concept or ability is classification, and by the end of middle childhood, children pass Piaget's class inclusion problem. They can now group objects into hierarchies of classes and subclasses. Collections become common in middle childhood. And this is, if you can recall, this is why you learn different types of animals, amphibians, reptiles, and so on. And you were able to classify different types of animals based on those broad classes or even subclasses, different types of trees, and so on. In addition to that, there is spatial reasoning that is acquired, and Piaget found that school-age children have a more accurate understanding of space than they did earlier. Middle childhood brings improved understanding of distance, and by the early school years, children understand that a filled-up space has the same value as an empty space. In terms of directions, between 7 and 8 years of age, children start to perform mental rotations in which they align the self's frame to match that of a person in a different orientation. So as a result, they can identify left and right for positions they do not occupy. Around 8 to 10 years, they can give a clear, well-organized direction for how far to get from one place to another by using some sort of mental walk strategy in which they imagine another person's movement along a route. So I continue. So why does the child display different levels of understanding conservation that seem to require the same mental operations? And Piaget noticed that some forms of conservation, even going back to conservation, are understood much sooner than others. You can understand mass much earlier than volume. And he was aware of this and coined the term horizontal decalage. A very, very important concept. So what is horizontal decalage? According to Piaget, horizontal decalage is that term for children's uneven cognitive performance, an inability to solve certain problems, even though one can solve similar problems, requiring the same mental operations. So horizontal decalage occurs because problems that appear quite similar may actually differ in complexity. For instance, children understand conservation of volume much later on, until they have reached the age of 9 to 12, because it is a complex task that requires the child to simultaneously consider the operations involved in conservation of both liquids and mass, and then determine whether there are any meaningful relationships between these two phenomena. So Piaget always maintained that operational abilities develop gradually and sequentially as the simpler skills that appear first are consolidated, combined, and reorganized into increasingly complex mental structures. So just to bring to your attention, just looking at what really is horizontal decalage, pay attention to what it means, go over what it means, and I think you should be okay with that concept. In moving on, looking at information processing very, very quickly, just to give you an idea of what it is, during middle and late childhood, long-term memory increases in terms of knowledge and expertise. During middle childhood, children arrange the vast amount of information in their memories into increasingly elaborate hierarchical structured networks. Knowing more about a particular topic makes new information more meaningful and familiar, so it is easier to store and retrieve. Children who are experts in a particular area acquire knowledge more quickly and actively use what they know to add more by the end of the school years. So knowledge acquisition and use of memory strategies are intimately related and support one another. So we have memory strategies, and these are deliberate and mental activities we use to store and retain information. We also have rehearsal and organization, very important during those years, where rehearsal involves repeating information to oneself over and over. Organization is grouping together related items. Older children organize more skillfully, use organization in a wider range of memory tasks, and memory strategies require time and effort to perfect. At first, control deficiencies are evident, and younger school-age children use of multiple strategies has little impact on performance, what we call a utilization deficiency. So as I move on, just to understand what we mean by fuzzy traces or fuzzy trace theory, is that theory that states that memory is best understood by considering two types of memory representation, what we call verbatim memory trace and gist. In verbatim memory trace, it consists of a precise details of the information, whereas gist refers to the central idea of information. When gist is used, fuzzy traces are built, although individuals of all ages extract gist, where young children tend to store and retrieve verbatim traces. At some point during the primary school years, children begin to use gist more. And according to this theory, this contributes to the improved memory and reasoning of older children, because fuzzy traces are more enduring and less likely to be forgotten than verbatim traces. So this gives you an example of what is happening in terms of fuzzy traces and fuzzy trace theory versus verbatim trace and gist. So I want to close this section. I will finish off in terms of information processes, and then I will begin socio-emotional development right after in part 3 of